Okay, next we have anomalous Zeeman effect. Now this I can define it first. The splitting of a single spectral line into a number of components line. Number of components line which will be more than 3. More than 3. In the presence of weak magnetic field is called anomalous Zeeman effect. Like a normal Zeeman effect, a single light either split into 2 or 3 components depending on the direction of observation. If we observe the splitting of spectral line in a direction parallel to the magnetic field, then there are 2 components. If we observe the splitting of light in a direction which is perpendicular to the magnetic field, then we have 3 spectral lines. Now, if a single line is split into more than 3 components, a number of lines, component lines means more than 3 components, but the condition is here we use a strong magnetic field, here we will use a weak magnetic field, then this phenomena is called anomalous Zeeman effect. Now, as I already discussed in the spectrum of sodium, that the principal series, like in sodium spectrum, we have the principal series and the principal series comes from the transition from NP to 3s, where N is 3, 4, 5 and so on. And we already discussed there that each single line of principal series contain 2 spectral lines, 2 components line. One is called D1 and the other one is called D2. D1 comes from the transition from 3 doublet P 1/2 to 3 doublet P 3 doublet S 1/2, and one is comes from 3 doublet P 3/2 to 3 doublet S 1/2. Now this is the spectral line with highest wavelength. Its wavelength is 5896 angstrom, and this spectral line has a wavelength which is 5890 angstrom. This is called, this smallest wavelength spectral line is called D1, and this is called D2. Now when this spectral line passes through a weak magnetic field, suppose we have D1, which is a single line in the absence of magnetic field when B is 0, and here we have the D2 line, which also a single line, looks like a single line in the magnetic field when the magnetic field is 0. This is, I call it D1. Its wavelength is 5890, and this is D2, and its wavelength is 5896 angstrom. These two lines are 6 angstrom away from each other. This is what we call it, sodium doublet. Now once we pass these two spectral lines D1 and D2 through a weak magnetic field, then this D1 light split into 4 components line. And this D2 line split into 6 component line. So this single line split into 6 spectral line, and this single line is split into 4 spectral line. This is when B is not equal to 0, but the magnetic field is weak magnetic field. This is called anomalous Zeeman effect. Now, why we call normal Zeeman effect as a normal Zeeman effect, and why we call anomalous Zeeman effect as anomalous Zeeman effect? The reason behind this is very simple. Like normal Zeeman effect can be explained by using both classical and quantum mechanical theory, while anomalous Zeeman effect can be explained only by quantum mechanical theory, while we cannot explain it by using the classical theory. Like normal Zeeman effect can be explained by using classical theory, which we call it Lorentz theory, given by Lorentz, and it also can be explained by using quantum theory, while anomalous Zeeman effect can be explained only by using quantum theory. So in the next video we will explain normal Zeeman effect by using classical theory, also by quantum theory, and we can also explain anomalous Zeeman effect by using quantum theory. That why this spectral line, like D1 line, is split into 4 and D2 into 6, and why zinc singlet is split into 2 or 3. Yeah, this can be explained by using both classical and quantum mechanical theory, and this can be explained only by using quantum theory. Thank you.